Hello, so in this video we're going to learn about how to transform our truncuses. So as you remember, the standard form for a truncus, is going to be this. And we've actually done some things here with -6, which is going to change our horizontal asymptote, and we have a 2, which is actually just going to cause a dilation away from our x-axis, but we don't really have to worry too much. It's not going to really impact how we draw it. It's going to impact what our x and y intercepts are, so it is still important. So the very first thing we're going to do is I'm going to go, all right, I have this -6. I know that this -6 is going to mean that my asymptote, let me write here asymptote, my asymptotes are going to be y equals -6. Nothing is happening to my vertical asymptote, so it's going to stay at x equals 0. So I'm going to draw those in. My vertical asymptote stays the same as a standard rectangular hyperbola or truncus, or it's going to stay there, and my horizontal asymptote will now be here, y equals 6. That's really all the information I need now, because now I can draw it. It's just your standard truncus. There we go. And now I need to find my intercepts. I have an intercept here, I have an intercept here. To find x int, let y equal 0. So 0 equals 2 over x squared minus 6 plus 6 to both sides. Do some fancy rearranging. Do some more rearranging, simplification rather. So I'm going to be left with x equals plus or minus 1 over the square root of 3. That makes sense that I have a plus and a minus because I have two intercepts, one on the positive side and one on the negative side. So this is going to be 1 over the square root of 3, 0, and this will be negative square root of 3, 0. Perfect. Let's now move on to our next example, which will be this one. So again, just by looking at it, the first thing I would do is write down what my asymptotes are. So what are my asymptotes? Actually, let's do ... Well, this tells me what my y1 will be. It will be y equals -6. And right here, this tells me that my vertical asymptote has changed. It will now be x equals +2. Remember, if this is negative, it means it's shifted 2 in the right. And the reason for that is because x minus 2 squared cannot equal 0. So after my rearranging, x cannot equal 2 because 2 minus 2 is 0. And I cannot have my denominator being 0. Perfect. Now that I have my asymptotes, I quickly draw those in. X equals 2 will be here. You, of course, will use a ruler, and this will be y equals -6. I can then draw in my truncus. Perfect. So as you can see here, I have two x-intercepts, and I also, let me do this in orange, have a y-intercept. Let's find my x first. So to find x int, let y equal 0. So I'm going to get 0 equals 3 x minus 2 squared minus 6. Rearrange. I might run out of room here. I'm going to get x minus 2 squared equals 3 over 6. I'm going to have to come up here now. So that's going to be x. I'm just going through every step. So if you wanted to, you could skip a few steps if you felt so confident to do so. I'm going to square root both sides. Plus or minus 1 over the square root of 2. Going to plus 1, 2 to both sides. Plus 2. So that will be my x-intercept, and perhaps a prettier way to write that would be 2 plus or minus 1 over the square root of 2. But you wouldn't get marked down for doing it either way. So the one that is more positive, has a greater x value will be 2 plus 1 over the square root of 2, 0. And the one with a smaller one will be 2 minus 1 over the square root of 2, 0. And now I need to find what my y-intercept is. Let me do that here. This will be a little less. Oh, this isn't orange. It's very important to find y-int let x equal 0. So it's going to be y equals, I'm going to skip a few steps here. It'll be 3, 0 will be here, minus 2 squared will be 4, minus 6. I could then get a common denominator. So I'm going to times this by 4 to get 24, and then have 4 down there. So it will end up being negative 21 over 4. So that means that this value here will be 0, negative 21 over 4. Let's now move on to my next one, which will be 1 over 3x minus 6. So let us here for a moment stop and just appreciate the fact that my horizontal asymptote will be the same. My y1 will not change. It's still going to be y equals 0. But let's remember that my denominator cannot equal 0. So if I was to write that out, 3x minus 6 squared cannot equal 0, then do some rearranging. So I'm going to square root both sides. I'm going to be left with this. And then I'm going to move my plus 6. And then I will be left with 6 divided by 3 is 2. And let's see if this checks out. If I put 2 in here, 3 times 2 is 6. 6 minus 6 is 0. So therefore, x cannot equal 2. And that therefore tells me that my asymptote, my vertical asymptote, will be x equals 2. I can then draw that in. And it's going to be clear that I'm going to have one y-intercept. So I can quickly find what my y-intercept will be. So to find y-int, let x equal 0. I'm going to skip some steps. 1 over, if I was to put 0 in there, 3 times 0 is 0, minus 6. I'm going to get minus 6 squared, which would be 1 over 36. So this value right here will be 0, 1 over 36. Let's move on to our next one. Again, I see that I have no plus or minus of a constant here, so that tells me that my horizontal asymptote will stay the same. It's going to be y equals 0. But again, I see here that things are happening to my vertical asymptote, and I know that this cannot equal 0. So again, I'm going to write 2x minus 8. I actually don't have to put that square thing there. All I need to really know is that this within this bracket cannot equal 0. So I can say will not equal 0, just to save us a step. So 2x equals 8x divide both sides by 2 will be 4. I can check this out. 2 times 4 is 8. 8 minus 8 is 0. Therefore, that wouldn't work at x equals 4. So I'm going to put that in as my vertical asymptote. X equals 4. I can then draw it in. And I'm going to have one y-intercept. What will that be? To find y-int, let x equal 0. I'm going to skip some steps again. 3 over, if I was to put 0 there, 2 times 0 is 0. I'm just going to be left with minus 8 squared. So it's going to be 3 on 64. And I'm just going to go 0, 3, 6, 4. And there it is. Perfect. Let's go to the, I'll leave it there for a second. So that's everything I did. Let's now move on to the next one. Okay, so for this one, I immediately upon looking at it know that both my asymptotes are going to change. So let me write in my asymptotes again. What are my asymptotes going to be? So just by looking at it, I know that my asymptote will be y equals positive 1. And then, again, you might just be able to do this in your head. You might just be able to look at that and say, well, it's going to be 1 over 5. Because if x is 1 over 5, 5 times 1 over 5 is 1. 1 minus 1 is 0. Doesn't work. So I know that this is going to be x equals 1 over 5. And I know that my horizontal one is going to be shifted up 1. And again, this is not to scale at all. I can then draw in my truncus. My truncus will look like this. I therefore need to find one y-intercept to find y-int let x equal 0. I'm going to skip some steps again, so I'm going to get 4. If I put 0 there, 0 times 5 is 0. We're left with negative 1 squared plus 1, which is going to equal 4 over 1 plus 1, which will equal 5. So this will be 0, 5. Perfect. Let's now move on to our lucky last. All right, so they're trying to scare us here. Not scare us, they're trying to trick us rather. They've put a 3 here, but that really doesn't make a difference. It's the same as putting the 3 there. So don't let that throw you at all. So this is still going to be for my asymptotes. Y equals 3. And what will my x asymptote be? Well, it's going to be where this cannot equal 0. And just doing some quick rearranging in my head, I get 2 over 3. Because 3 times 2 over 3 is going to be 2. 2 minus 2 is 0. So that is how you quickly solve that in your head. Then I'm going to draw it in. It's going to be right here. My y will be here. Again, this is not to scale. Okay, now, when it comes time to draw it now, there's one thing we need to be keenly aware of, and that is this minus. This minus is reflecting it across my x-axis. So instead of being like this, like it would normally be, it's going to be reflected across my x-axis, which will mean it's going to look like this. And therefore, I need to find 2 x-intercepts, and you should really draw arrows onto these. Hopefully I've been doing that in the past. Make sure you always draw arrows. 2 x-intercepts and one y-intercept. So to find x-int, let y equal 0. So I'm going to let y equal 0. I'm going to be left with 0 equals 3 minus 6. 3x minus 2 squared. I'm going to minus 3 from both sides. So I'm going to be left with this. Oh, This is going to get hairy. I'm actually going to scroll down. I'm then going to times this side up and be left with 3x minus 2 squared equals negative 6. I will then divide both sides by negative 3. Negative 6 divided by negative 3 will be 2. I will then square root both sides. So I'm going to be left with plus or minus the square root of 2. I'm then going to plus 2 to both sides. So I'm going to get 2 plus or minus the square root of 2. And then finally, I'm going to divide both sides by 3. So I'm going to be left with 2 plus or minus the square root of 2 over 3. So now I can come up here. Obviously the one that is going to be bigger, actually I need to see it, 2 plus or minus. So this is going to be 2 plus the square root of 2 over 3. And my y will be 0. And this will be 2 minus the square root of 2 over 3, and this will be 0. This line will be, I need to now find my y-intercept. I'm just going to do it. I don't know how I was going to do that. Let me come over here and go to find y-int, let x equal 0. So I'm going to be y equals 3 minus 6. If I put 0 into there, 3 times 0 is 0, minus 2. So I'm going to be left with minus 2 squared. I'm going to have y equals 3 minus 6 over 4, which is the same as saying y equals 3 minus 3 over 2. I then need a common denominator. So this will be 6 over 2 minus 3 over 2, which will equal 3 over 2. Too easy. So here, when this is 0, my y-intercept will be 3 over 2. And we have just solved it. So hopefully this is useful to you in your pursuits. And yeah, we've just gone through all the questions. These little videos are just supplementary. If you missed anything in class and you wanted to go over it in a bit more detail, here it is.